Welcome back to ME 760 Engineering Analysis 1. So we will continue the same business for solving the first order partial ordinary differential equation. Hopefully we will finish it by this lecture, today's lecture. Then we will move on to the higher order differential equations. When I pick up the book for you guys for this course, this book up to the last year, it was only single large volume or one volume book. So I thought that whatever material we'll be needing, it's only contained in the first book, but I discovered that the higher order differential equation is contained in the second book. So what I did is just I uploaded the chapter that we will be using. It's only 2 chapters, 70 pages for the higher order differential equation plus the series solution for higher order differential equation. If we need any other material, I will try to upload it to the internet. But again, this is a copyrighted material. I do not want anybody to play with just to use it for the sake of the exams and homework and so on. So if you will look at the K-State Online under, I think, handouts, the last one is called Higher Order Differential Equation PDF file. So this is where you will be using the handout to study the material for this coming chapter. Okay, guys? So let's start. So last time, we continue the same business for solving the first order differential equation. The first method to try was the separation or separable equations. And we stated that if the equation is simple and you can separate it, if it is, let's say, in a simple format, you can separate it and solve it without any problem. We showed also by the end of the last lecture tricks how to convert from a non-separable to a separable differential equation. Yes? So today's we will solve the exact differential. And the exact differential equation will take the form dy by dx multiplied by nx and y plus m of x and y is equal to 0. So you have a function n of x and y multiplied by the first derivative plus a second function m of x and y. So this equation will be exact if there exists a function u of x and y such that du equal to du by dx plus du by dy. So if you have a function u of x and y and the exact differential for the function u is just du, which is du by dx multiplied by dx plus du by dy multiplied by dy. So with m, if you want to correspond this function to this function, of course we will multiply by dy both sides. This will give you n of xy dy plus m of x and y dx equal to 0, and get the correspondence between the two equations. So if we will do this, this will be just dy, and you will have dx here equal to 0. So the correspondence now, this will be what? M of x and y will be what? Du by what? By dx, and n of x and y, which is multiplied by dy, will be this, which is du by dy. Okay, guys? And the solution for the differential equation will be just the integration of du is equal to what? 0. So u will be what? Will be constant. Yes? So if you happen to have the first order differential equation, dy by dx multiplied by a function of x and y plus a function of x and y without any differentials, dy by dx or any y. So this case, we can transform it easily to an exact differential like this. Okay, guys? And then we can solve it, the exact differential, as the integration of dy equal to 0, which means y equal to a constant. So what's dy? du? du is what? Which is what? N of x and y dy plus m of x and y dx. So a necessary and also sufficient condition for the exactness is the following. If you differentiate du by dx, differentiate it once more, but with y not right now. So d2u by dx dy, this will give you what? You differentiate with y, so this will give you d by dy for m and x, and differentiate du by dy, but now with x, so this will give you du by dy dx equal to dn x and y with respect to x. Okay, guys? So when you differentiate twice, what will happen? What did you find? This is equal to what? Is equal to this. So what's the conclusion now? dm of x and y by what? By dy equal to what? dn of x and y with respect to x. So this is the necessary and sufficient condition that this will be an exact differential. So n is multiplied by what in the first equation here? N of x and y multiplied by dy. So here you differentiate it with x. So take the first function multiplied by y and differentiate it with x, and take the second function multiplied by x and differentiate it with what? With y, and see if both are equal or not. If they are equal, so this is exact equation, and you can solve it just by du, integration of du equal to 0. Okay, guys? Okay? If it's not equal, so this is not an exact what? Equation. So this is the exact one. So now we will look at integrating factors. How to use the integrating factors. So the equation dy by dx multiplied by n x and y plus m x and y equal to 0. If it's not exact, if this is not exact, so we show how to solve the exact equation. Okay, guys? But what if the equation here, you differentiate n by dx and differentiate m with respect to y, and both terms does not equal to each other? So if they do not equal to each other, then we have to use another trick here. So after multiplication, or after multiplying by some special function, we'll call it f of x and y, so we will transform this to f of x and y. We'll multiply it here, and this will be multiplied by f and x and y also, and this will be 0. So we can make the equation exact. So did you understand what we are trying to do? So we have exact equation, easy to solve. How to figure out that this is exact equation? Differentiate n with respect to what? X. And differentiate m with respect to what? Y. See if they are equal or not. If they are equal, so this is exact equation. Solution is here. du equal to 0, du equal to the integration of n of x and y dy plus m and x and y dx, and u will be equal to some constant. What if the differentiation of n with respect to x does not equal to the differentiation of m with respect to y? So we have to try to do some tricks so that we will convert the non-exact form of the equation to an exact form. How we will do this? By multiplying by a function f of x and y both sides, so that we will make this equation exact. So how you will make it exact? You will say that now the function, the new function is what? F x and y multiplied by what? N x y, and the new function here is what? This function, and the differentiation of x and differentiation of y should make this function what? Exact. So we want to make the function exact so that du is equal to what? Fn dy plus fm dx. So we want to make this function here, if you multiply by dx, this would be fn dy plus mf dx. And this is what you see here. And we will call this function dy, and we want to make it exact. So let's look at an example here. How to make it exact. Okay, here is the example. dy by dx equal to negative 2/3 y divided by x. So this is also separable, yes, because dy over y equal to 2/3 negative 2/3 dx over x. And the solution, if you solve it with the separable method here, dy over y equal to negative 2/3 dx over x, this will give you ln y equal to ln x to the power of negative 3/2 plus c, and this will give you the solution as c prime over 2/3 x to the power 2/3. This is just the separable solution for this equation. This is what we took or investigated last time. Now we want to look at the solution using the what? The exact differential. So to make it as an exact differential, this will be what? This will be 3 dy 3x dy plus 2y dx equal to what? 0. So this is what? This is what function? M. And this is what function? N. Let's do the check. dn by what? By dx is equal to what? 3. And dm by dy is what? Equal to, are they equal? Nope. So they are not, the equation is not exact equation. So we have to multiply it by some function, f of x and y. You will multiply both sides. And if you multiply both sides of equation by the same function, you do not introduce anything. Yes? If you multiply here, let's say x, 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 did you make anything? No. Yes, guys? So the function that we will be using to multiply is f of x and y is equal to x y square. So if you multiply this function by x y square, this will give you what? 3x what? Square what? Y what? Y square. Yes? dy plus 2 what? X y squared. Yes? Y cubed. Sorry. dx. And this is equal to 0. Now this is again what? And this is again what? N and m. So what's dn by dx? 6 x y square. And what's dm by dy? What? Are they equal? Yes. So what we did is we multiplied. It's not an exact equation. We multiplied by what? By a function f of x and y both sides. It does not introduce any difference to the equation, because if this is equal to 0, you can still cancel f of x and y from both sides as a common factor. Yes, guys? You take it as a common factor outside, then you divide by the same function both sides again, and you will end up with this equation. So now the equation is exact, and the solution for the equation is just what? Du equal to what? M dx plus what? N dy. And this is the equation. So m dx is what? M is 2x y cubed. We'll integrate it over dx plus 3x square y square. We'll integrate it over dy. And the integration will be equal to some constant here. After you integrate, this will give you some constant. So what's the integration of the first one? X square y what? Y cubed plus xy square y cubed equal to what? Some constant c, or this will give you 2x square y cubed is equal to c, or y will be equal to what? C divided by what? C divided by 2x square, but this is a constant, c prime divided by x what? Yes, guys? Because this was what? X cubed. You will take the third 1/3, which will be the 1/3 of this, and 1/3 of a constant under the square root of third square root, or third root will be another constant. So the solution here is exactly the same. Yes, so it was separable, so it was very easy to do the what? the solution just by the separation method and just direct substitution. And also, we show that the solution for exact equation will give us the same. So we can solve it by two methods, the separable method and the exactness method, okay? Okay, guys? So we showed that, okay, the sufficient and necessary condition for exactness is dn by dx equal to dm by dy. If it's not equal, think about something. And when you think, guys, about something, you will say, okay, this equation here, how I will make it d by dx here equal to d by dy. So you can say, I need dn, okay, dnf by dx. Yes, guys? Is it n multiplied by dy? So dn by dx, now the function, the new function is nf, is equal to what? dmf by what? By dy. So you can in principle find the factor that you want, which is the equation f. So it will be dn by dx plus what? df by d what? By dx equal to dm by dy plus what? df by dy. You knew this, yes? And you knew this, and then you have this term, and all what you will do is you have to find a function that if you differentiated with respect to x minus the same function if you differentiated with y will give you the difference between those two functions. So if the function, if you cannot solve it by just visual inspection, here we did it by visual inspection. We said xy square, for example. But what if the function is not x and y, the function is cosine e to the power of x, for example, and sine e to the power of y from the other one. So you can do something like this so that you will figure out how you will get the f function. Okay, guys? So you will have the difference between those two terms. Then you can think about a function if you differentiate it with respect to x minus the same function if you differentiate it with y will give you this difference. Now, let's move on to the second type of equations. We studied what? The separable method, the exact method. Then we will look for the linear first order, ODE, how to solve the linear first order ODE. So this is dy by dx plus p of x multiplied by the same function y of x equal to q of x. So this is usually the form of the first order differential equation, linear differential equation. And this equation is inhomogeneous because I have a q of x term here. So the steps of solution, step number one is you will find an integrating factor again, like what we did here. So integrating factor. So the other equation was the exact equation. We do not have in the exact equation, if you do not have y of x, this will be what? The exact equation. Yes? Because the exact equation is what? Some function here, n of x and y, this is a constant, this function is a constant, and some function, m and x and y. If you do not have this and this is just 1 or 0, if this is 0, m and x and y would be negative q of x. Yes? If this is 1, m and x and y will be b of x minus q of x. Okay, guys? So now we want to get an integrating factor such that when you multiply f of x by dy dx plus f of x again, you multiply it by p y, this will give you an exact differentiation like this. Why we are making this? So guys, why we are making this? Because here it is. If we find a function that will multiply here f of x and y, okay guys, we'll multiply it here, and f and x and y will multiply it here, okay guys, and f and x and y will multiply it here. So this term is still what? The inhomogeneous term. Yes? So now, if we find this term, that if we multiply here f of x and y dy by dx, and then f of x and y, p of x, y of x, so that we can write this term as an exact differentiation for f multiplied by y. So if you have two functions multiplied by each other, d by dx, this will give you what? What? The first multiplied by what? The second plus the second multiplied by what? Yes? Multiplied by the first. So in order to make this equal to this, so those two are what? Are same. Yes, guys? Those two are same. And here, y from here is equal to what? Y from here. So in order for those two terms to be equal, I require what? I require df by dx to be what? F of x multiplied by p. Yes, guys? So you require that df by dx should be equal to what? F multiplied by p. Yes? In order to make it exact differential. Why we want to make it exact differential? So that if we multiply by f of x both sides, this would be what? F dy by what? By dx plus b multiplied by what? By f multiplied by what? Y equal to what? FQ. We said that this is exact differentiation, so this will be what? dfb by d what? By dx will be equal to what? FQ. Then when you separate the variable, this will be fp equal to what? FQ dx. Yes, guys? So d of something, the differentiation of something, when you integrate, it will give you what? The same thing. So this will give you what? FB equal to what? Yes? And then you can find the function f, for example. This is fy, sorry guys. I made a mistake. I said it does not make sense. Fy is equal to this. So what's y now? Y will be what? 1 over f multiplying by what? Multiplied by the integration of what? FQ ds. Did you understand why we want to transform it to an exact differential like this? Did you understand? So how we will get f? I just wrote the condition for f over there. If df by dx equal to what? So this will give us what? df over f equal to what? B what? B dx. So what's f now? Ln f is equal to what? P dx. Yes? So what's f? E to the power of c multiplied by what? E to the power of p dx. We can choose any arbitrary constant c, and we can take c as what? 0. So if c is 0, f will be what? So this is whatever f you are asking for. So how to solve first order linear differential equation? Is you said dy by d what? By dx plus p of x multiplied by y again equal to q of x. So the first thing is to multiply by what? By the integrating factor. What's the integrating factor f? F is equal to what? You will take this and you will raise it to e to the power of b of x dx. This is your integrating factor. Then if you multiply both sides by f, this will give you what? E to the power of the integration of b of x dx multiplied by dy by d what? By dx. And this will be what? B of x e to the power of b of x dx multiplied by what? By y equal to what? Q of x e to the power of b of x dx. Can we write this as d by dx for y multiplied by e to the power of b of x dx or not? Can we write it like this? The first multiplied by the differentiation of what? Of the second, which is this. Yes? The first multiplied by the differentiation of second. First multiplied by the differentiation of second, dy by dx. Plus the second, which was what? Y. Multiplied by the differentiation of the first. Differentiation of the first is what? The same function multiplied by the differentiation of the integration of p of x dx. What's the differentiation of the integration of b of x dx? B of x dx, which is this term. Yes, guys? So what we did is we transformed this to be what? Exact equation here. And this would be equal to what? Q of what? Q of x e to the power of b of x dx. How to solve this now? How to solve it? Just separate the variable like what we did every time, and this will give you what? D what? Dy e to the power of what? B of x dx equal to what? Integration of what? Q of x e to the power of what? B of x dx. Yes, guys? I did not do anything, just separate the variables. Yes, guys? Okay, guys? So what's the solution for this one? du. What's the integration of du? U. So if we call this u, so du, the integration of du will just give us what? U. And what's u? Y e to the power of p of x dx equal to the integration of q of x e to the power of the integration of b of x dx. So I can separate y plus constant c. So y will be what? E to the power of minus b of x dx multiplied by c plus the integration of q of x e to the power of p of x dx. So this is the solution of the equation. Okay, guys. So to take an example, which is the radioactive decay for a nucleus. If you have some radionuclide at time t, they are n of t, you are producing this radioisotope by certain production rate, which is q naught is a constant, and then you decay by negative lambda multiplied by n of t. This is the rate of decay. So what's the equation that gives you the time rate of change of this? So the time rate of change of the number n of t is equal to the production, and the production is just what? Q naught minus the what? Minus the decay, and this is the decay lambda n of t. So if you rearrange this equation, this will give you the n of t by dt plus lambda n of t equal to q naught is a constant. So what's the function f here? Will be, this is the p of x. Yes? This is the y, this is the y, this is the p, this is the q. Yes? So what's the p of x is a constant, is what? Is what? This is not y. If you stand in your head, this will be y. So make something like this. Look from down, it is y. But it's lambda, not y. So f is equal to what? E to the power of lambda dt. But lambda is constant. So this will be what? E to the power of lambda t. Multiply here e to the power of lambda t multiplied by dn of t by dt. Yes? Plus lambda e to the power of lambda t n of t equal to q naught e to the power of lambda t. Now, look at those two terms. You can write those two terms as what? D by dt multiplied by e to the power of what? Lambda t multiplied by what? By n of t equal to q naught e to the power of lambda t. Why? The first n of t multiply e to the power of lambda t multiplied by the differentiation of the first. So it is e to the power of lambda t dn by dt plus the second n of t multiplied by the differentiation of this, which is lambda multiplied by e to the power of lambda t, which is lambda e to the power of lambda t. Okay, guys? Equal to this. So now I can write it as what? D e to the power of lambda t multiplied by n equal to q naught e to the power of lambda t dt. At time t equal to 0, we have the initial number of radionuclei n naught. At time equal to t, we have n of t. So what's the differentiation of this? This will give you what? E to the power of lambda t multiplied by what? N of t. Yes? So at time t0, this will be what? 0. E to the power of 0 is what? 1. And n of t? is n naught, so n naught. Yes, and this will be what? N of t e to the power of what? Lambda t. So this will give you what? This is q naught is constant, e to the power of lambda t dt. So this will give us n of t e to the power of lambda t minus n naught equal to q naught multiplied by the differentiation of what? Differentiation of what? The integration of this is give you what? Q naught, so it will give you lambda e to the power of what? Lambda t from 0 to what? 0 to t. So all what you're saying is n of t e to the power of lambda t gives you n naught plus q naught over lambda and multiplied by e to the power of what? Lambda t minus e to the power of 0 is what? Minus what? Q naught over lambda. So now separate and get n of t. So n of t will give you what? N naught e to the power of minus lambda t plus, this will give you what? Q naught over what? Q naught over lambda multiplied by what? 1 minus e to the power of minus what? Okay, guys? Okay? So what did you get here? What did you get? You get n naught equal to n naught e to the power of minus lambda t. What's this? This is the solution for this equation when there is no production, just decay. Yes? So this is the solution for what equation? Homogeneous equation. So this is what? Homogeneous equation solution. And this is the solution when we have what? Q naught. So if Q naught is equal to 0, this will be what? 0. So this is the solution of what? In homogeneous equation solution. So this is the particular integral. We call it particular solution. So this is the particular solution, and this is the homogeneous solution. Okay, guys? So I will conclude just with direct reduction of nonlinear to a linear equation, and then this will be the conclusion for the last chapter of the first order differential equation. Then from next lecture we will start the solution of the second order and higher order differential equation. Again, it's not in the book, I just uploaded to the internet. So we'll talk about the reduction to linear equations. And the reduction to the linear equation, many of the nonlinear equations can be reduced to a linear ODE by some clever transformation. So if we talk about, for example, one of the equations is Bernoulli equation. The equation is just dy by dx plus p of x multiplied by y of x equal to q of x or g of x multiplied by y to the power of a. So now This is no longer the first order linear equation because we multiply by what? Y as to the power of a. So in this case, all what you can say is, you can say, I will pick up a function u of x equal to y of x to the power of 1 minus a. You call it 2. Differentiate this, so du by dx is equal to 1 minus a multiplied by y of x to the power of minus a, because 1 minus a minus 1 is to the power of minus a, multiplied by dy by dx. And you can rewrite this again. You can rewrite this again as 1 minus a multiplied by y to the power of minus a multiplied, what's dy by dx from here? It's g of x. This is g of x multiplied by y to the power of what? A minus p multiplied by what? By y. So this will be 1 minus a multiplied by, multiply here, y minus a goes with each other. So multiplied by here and here minus p multiplied by y 1 minus a again. So what's y minus a? Y to the power of 1 minus a. This is g of x and minus p. What's this? So this is u. Okay, guys. Now I have u prime, which is this, du by dx, u prime equal to 1 minus a multiplied by g of x minus p multiplied by u. So you transform it to the same equation again. du by dx plus what? Bu multiplied by 1 minus a, b multiplied by 1 minus a multiplied by u equal to 1 minus a multiplied by g of x. So now I converted a nonlinear first order equation to a linear first order equation. Then you can solve this and you will get what? With the integrating factor you will get what? U. So what's p of x here? 1 minus a multiplied by p of x. So the integrating factor will be e to the power of what? Integral of p 1 minus a. Yes? Dx. Then you will solve it, you will get what? U. Then you will come back here, you got u of x. So you will take the square root of the root of this will be y equal to what? U to the power of what? So once you solve for u, you will go back and solve for what? Solve for y. So does make sense for you guys? Okay. Have a wonderful time and see you all next week.